Hi, this is Bob Haley with Quemby, and we provide an automation platform for software deployment and cloud hosting, and we do it faster, better, and cheaper. What we really do is deploy an autonomous Kubernetes platform to orchestrate and synchronize all the open source technology and compute resources to better automate the software lifecycle, auto-scale the resources, and eliminate technical debt. And when we do that, we provide 100% governance, we double your productivity, and we do it at 2/3 the cost. This is a pictorial of the CuembyIO platform. And what you can see in the middle there, they are just bare metal resources from all of the cloud providers. And 7 o'clock there is a premises-based data center. The layer out from there, what you can see are the containers, the microservices, all of the resources and the infrastructure. The next layer is governance. It's security, observability, and traceability. And the outer layer is really the only layer that a customer will interface with, which is the application layer, where they can deploy all of their software and manage all of their resources through one simple interface. And the tech stack underneath this picture, which is here, is completely automated with 100% governance against default configuration best practices. Now, it's very configurable, and all of this tech stack that you see here, again, it's orchestrated and synchronized, but if there's a particular technology that you want to use, we can replace that. That's where the platform becomes very configurable. But if you want to just have a simple plug and play, not know what's underneath the hood, and have everything work efficiently, that's what CuembyIO provides, with Kubernetes serving as the foundation to orchestrate and synchronize all of those open source technologies. And now what we want to do is show you a demonstration where Angel, who's on the call with us here, he's going to show you how by pre-configuring the platform correctly, we can achieve horizontal autoscale based upon a heavy load. We're going to show you how we can replicate across multiple clouds and multiple regions, and multiple providers, multiple regions, and show you an example of the pipeline with software, with the software lifecycle automation. So with that, I'm going to let Angel take control.
Awesome. Well, as you said, CuembyIO has it. So first thing first, what I'm going to show you real quick is first, look at my right-hand side, which is also your right. So we have some pod, which is the container that we are scaling. So if you can see here, we have nothing. So this is where we don't have anything running. So what I'm going to do now, I'm just going to trigger some actions, and you will see how it's going to quickly start spinning new containers. And at the same time, it's going to just do everything that he needs at that time. And when it's done, it's going to just decommission all those containers and get back to the normal state. So let me just real quick launch that example. I'm just going to put some information real quick in my form. It really doesn't, it's not important, it's just for me to show you. So look at the right-hand side, where you're going to see all this pot coming on, starting to load based on that load. So right now it's spinning, literally it's about 10 to 12 jobs at the same time, because you need to literally just make those tasks in parallel. And you can see the status of the container. It says, some of them say pending, some of them says creating, and you can start seeing some of them will say completed. But for those that you see completed, you need to take a look at the numbers. It says 0, 1. That means that pod did his job and gone. There's no more pod. So you only literally paying for that specific job that he did literally in seconds. And you can see now they're going to start saying completed, completed, completed. So we launched about what, almost 20, and they're just going to start shut it down as soon as they're done. So that's kind of how I can show you what the auto-scaling means, and that's what basically horizontal auto-scaling.
And Angel, on the far right-hand side there, where it says from the bottom up, 39S, 39S, 18S, that stands for 39 seconds, or how long of a runtime that you were paying for compute resources. Is that accurate?
He's correct. That's all it took.
Okay. Yeah, good. Thank you. So that's an example of the horizontal auto scale based upon load for the containers. The next example we want to show you is how we can replicate the application across multiple clouds, meaning providers, in multiple regions. As an example, maybe it's AWS West Coast and Google East Coast. So Angel's going to show that to us next.
Absolutely. So now let me just go back to the other demo real quick. So here I'm going to show you a couple of things, right? So we have one second here, just to get ready. So in my left, you will see that it's a website and it's a nice octopus there clapping. But what I want you to pay attention is when you see the background is changing. It's basically changing from east-west in different cloud providers. So literally I have this application deployed in 2 cloud providers, 2 separate clusters, one on the east side, one on the west side. It really doesn't matter. It could be AWS, Google Cloud, DigitalOcean, whatever you prefer to do. But if you can see, it's responding 50-50. Right now, that's what I have. And I'm going to send some load, and I'm going to show you how it's basically handling the load internally. Because some of the east-west splitting traffic, it basically is done through DNS, which is very slow. Here it's basically done everything through networking internally, so which is very fast. So I'm going to show you the tab real quick. So I want you to look at my left, how it's going to start doing all the requests and see how it's handling very fast without losing any type of performance. So look at this. I'm just going to send I'm going to copy the URL real quick, and I'm going to post it in here. And I'm starting right now and sending 10,000 requests, 100 requests concurrent. So basically it's hitting the server very fast, and as you can see there, it's loading everything with no problem, right? And if you can see, all the requests are on the 1 millisecond, so some of them even under that time, which is very fast to reply. And I'm sending 100 concurrent requests. It's 10,000 in total, all within a minute. So that's a heavy load for the first.
Right, and this is the balance of multi-region and multi-provider. And when you combine this with what we talked about prior with the horizontal auto scale, that's how you can attain incredible resiliency for your application, while at the same time only paying for seconds or maybe minutes of runtime versus full-blown servers or VMs.
Yes, and the interesting part here though is that it's done that part, but I want to show you one more thing here. As you can see, I'm basically loading this website. It's on the West Coast, and it's calling the East. So I'm gonna show you real quick how can I, and this is very interesting to show you, how can I change that real quick? And instead of sending information to the East Coast, I'm gonna say I want that the West Coast send 100% of the traffic to the East Coast, regardless of whatever is happening. So I'm just gonna send that real quick. And all this stuff is happening automatically behind the scene. And the traffic, I'm making sure that that change gets applied. And from now on, it's only gonna reply.
Only going east.
That's it. It won't change. It's only East Coast. So that means that regardless where you are, it will be.
And the earlier dashboard we looked at was from Linkerd, and that's part of the tech stack that is automated and synchronized underneath the CuembyIO platform.
Correct.
Yep.
Yes.
Good. Okay. And then for the third thing that we want to show now is the software lifecycle automation, where we can, have some QA and testing that's automated in order to deploy code. Okay.
So this is the other example, and as you can see here, I'm on my right-hand side. I have just a website that it takes one parameter and say and translate it into Spanish, right? So it will say that when you send hi, it says hola. So what I want to show you here in my left hand, you will see that I'm just coding, right? So me as a developer coding, and I want to make sure that the translation, instead of being hola, should be something else. So I'm just gonna make a real quick change and say, well, let's send just hola with a small exclamation point. And if you can see on my left-hand side, it's basically pick up those events, and it's giving me, oh, okay, Angel make a change. So let me make sure that I can build that real quick. And that's the experience that the developer should get. very fast. I just made a change. I just want to see it online. And it's basically building the whole repository and make sure that my changes get deployed. Let's just give it a second. Usually it takes a little time to just load. So once it's done, it will give me a feedback. In the meantime, I want to show you that it's running the test. If you can see here, it says everything passed right now because I have the test and everything is good. But what I'm going to show you next is what happened if one of those tests fail. So let me just show you real quick that the actual change made. So I got the all with the exclamation point. So what happened if one of those tests change? I'm just gonna arbitrarily just change the test and say, well, let's say that because one of the things that we have in coding is that we have unit tests and other type of tests. I'm just gonna assume that something broke in my system, and I'm gonna make it fail. So I'm gonna save that, and it detects the change. It's gonna do everything again. It's gonna go through the building process. It's detecting that nothing has changed so far in the code, but it's gonna detect that one of the tests is not gonna pass, so it's not gonna deploy. And it's gonna stop me right there and say, no, there's something wrong here. You need to fix it. And that's the type of feedback that every developer should have, making sure that every time that they make a change before going to live production, whatever the environment is past your test. So as you can see here, it says one failure and it's not deploying. You see, it's saying it's keeping deployed due to an error running a structured test.
Right.
And that's how we make sure that all the tests passes before going live.
Right, and that's automation, because now what you've eliminated is the need for, whether it be software developers or engineers, to be watching their code and spending extra time to test before they deploy. It's been automated for them, and you can speed up and have more rapid deployment of updates because that cycle can be shortened. Is that accurate?
It is accurate, and this is just pretty simple scenarios, but there's so much that compose the software lifecycle, and this is how we can make it automated.
Got you. Great. Well, thank you for those examples. I appreciate it.
Awesome. You're welcome.